So section A was all about just evaluating specific values. Section B was all when the area was all above the x-axis. Section C was all below. And now we're going to look at finding not just the area between one curve and the x-axis, but between two specific curves. All right, let me kind of cover this part up and talk about this. So let's think about if I have a function, if I have two functions, and we want to evaluate from A to B. Think about if I just want to find f of x, the top function, I do everything from the curve to the x-axis. That's everything under f of x. Does it make sense if I want to go from f of x to g of x? I just need to, let me see if I can do this again. From A to B. If I just want this area, because I think, oh, I can do this, I guess. At first what happens is I get, oh shoot, I don't want all that. At first what I get is everything underneath, including this part, right? But if I don't want this part, if I just want from the top curve to the bottom curve, I just need to subtract this out so that I'm left with just the area in between. So if I take the area of the top curve, which is everything between the curve and the x-axis, then subtract out the integral of the bottom curve, I'm left with what's in between. So in general, hopefully this makes sense. I just take the top curve and I subtract the bottom curve. All right. So when we look at the proof, what they did was they took both curves and just moved everything above the x-axis. So notice they just added a k, a constant, to move everything above. Take the entire top minus the entire bottom. Well, think about if I take now the k values will just subtract, so that goes away. And I have f of x minus g of x. See how these proofs aren't meant to be tricky? You're just trying to get to the final result in common sense way. Okay, so getting the actual values are kind of tricky. So a lot of times you won't have the area. And so the first thing we have to do is where do these two functions, where do they intersect? So we want to figure out where does this equation meet this equation. I'm just going to set them equal. Okay, so we now have a quadratic, so I need to get it equal to 0. So I'm going to subtract my x's, subtract my 2, so this whole side equals 0. The x's cancel. I get x squared minus 4. So then I'm going to just factor it out. So I get x equals positive 2 and x equals negative 2. So that's the area we're looking for, is going to be in between negative 2 and positive 2. So let me just do a basic sketch here. All right, so if I plug negative 2 in to my, that's just a line. It's going to be here, here, here. This is just a straight line, a slope 1, right? Because then when I plug in a positive 2, I get 4. So here's that first equation. All right, so I know they intersect here and here. So now I just need to graph this equation. Now, So if we just want to plug in, I'm just going to plug in -1, 0, and 1 into this equation. So if I plug -1 in, that's going to be 1 minus 1 minus 2. If I plug in 2, 0, I also get -2. And if I plug in a +1, I get 1 plus 1 is 2 minus 2 is 0. That's not right. Oh, yeah. Never mind. I was thinking something else. All right. So 1, 0, 0, -2, 1, -2. Boy, this is really awkward. And then that just goes up there. Because they intersect at -2, 0, and 2, 4. So the important thing for the sketch is to figure out which equation is on top. So the line is on top of the quadratic. So what we're going to do, we're going to integrate from -2. You're always doing the x-axis for your order of integration. My top curve is x plus 2. Use parentheses because now we're going to subtract the bottom curve, x squared plus x minus 2. Then we want to simplify this as much as possible. So I'm going to distribute my negative and combine all my like terms. So this is my only -x squared. The x's cancel, and 2 plus 2 is 4. Now we're ready to integrate. So add 1 and divide from -2 to +2. All right, I'm going to do my math up here. All right, so plug in +2, that's -8/3 plus 8 minus, plug in -2, that'd be -8/3, that'll make it negative, we'll make it positive. So +8/3 minus 8. All right, so I'm going to go ahead and distribute this negative, because then what I get is -8/3 and -8/3 is -16/3 plus 8 and 8 is 16. So now I get my common denominator, multiply top and bottom by 3. So that's 48/3. So -16 plus 48. I get 32/3. So these problems have a whole lot more work to them, but it really should help your algebra. So take your time. All right, last problem. Find the total area of the regions enclosed by these two curves. All right, so the first thing I'm going to do is set them equal to figure out where do they intersect. So I need to move everything over to be with my x to the third. I always like just having the degree positive. So I'm going to minus the x squared. It doesn't match anything. Minus the 3 from both sides. So I see this cancels. Oops. Combine all my like terms. And I don't have a constant, which is good because now I can factor out my x. Because this is now factorable. Notice how much we're factoring, but none of them are hard, so that's good. All right, now we have 3 x's, 3 places that they intersect at 0, at 3, and at -2. We set them equal to find the intersection points. All right. Now, what also might be helpful, let's find the actual points of intersection. I'm going to use this equation because it'll be the easiest. If you plug in 0, I get 0, 3. If I plug in 3, 3 squared is 9, plus 3 is 12. Plug in -2, that's 4, 7. So these are the 3 places that they intersect. So we need a really good visual. All right, so 0, 3, 3, 12, -2, 7. Those are our 3 places that they intersect. Okay, so for this whole x squared plus 3, do you see this is just a parabola up 3? So it's really just that parabola right there. All right, so my cubic, then, I've got to hit all these points. So it's going to intersect here, and intersect here. And I still have to have a cubic shape. So it's going to be close enough for my purposes. So maybe not perfect, but because what I can see here is this area, that was weird. This first area here, let's call this area 1. Notice the cubic is on top. So I'm going to find my area 1 by integrating between -2 and 0. And I'm going to do the cubic, the top one, minus the bottom one. Because what happens here at 0, 3, the green now is on top. The quadratic is now above. You always want to take the top minus the bottom. All right. So I'm going to distribute this and combine my like terms. And the 3's cancel. These are out of order, but that's not a huge deal. Now I'm ready to take my antiderivative, add 1, and divide. When I add 1 here, I get 2, and divide by 2, I get 3. And I'm going to do that from -2 to 0. Now, I'm just going to, for sake of time, you plug in 0, you get 0 minus, plug in -2, -16/3. So when I take 0 minus 16/3, this is my area 1, this part right here. All right, now I'm going to do area 2. That's this right here. This goes from 0 to 3. And I'm going to take, now I have my quadratic function on top, x squared plus 3 minus the bottom function, x to the 3rd minus 6x plus 3 dx. Distribute your negative. So I'm going from 0 to 3. And I'll just start with x squared. The 3's now cancel. So these are just going to be opposites here. Plus 6x. I'll come over here and do my antiderivative. from 0 to 3. So I'm going to plug 3 in for all of this. And I'm going to get 15 3/4. And when I minus 0, it just stays 15 3/4. So this is my area 2. So my total area is area 1 plus area 2, 16/3 plus 15 3/4, which is 21 1/12. Yeah, I should have probably warned you this would take like a lot of space. So, but that's it.